Here we've got a capital budgeting project problem that's going to demonstrate a variety of different things. First, we want to be able to take a look at these two projects A and B, which have different kinds of flows of funds here. Project A, it's getting its funds later in time, but in bigger amounts. Project B is getting theirs a little bit sooner. And we want to see how that reacts to different values for the WACC at 5, 10, and 15%. So we'll calculate the NPVs for each of these scenarios, the modified internal rates of return, and the internal rate of return. Secondly, we want to look at decision making, the difference between having independent projects versus mutually exclusive. In the case of independent projects, we'll adopt everything with a positive NPV. Mutually exclusive, however, means you can only choose one. You want to choose the one with the higher NPV. And you can get a sense of how this looks with these other things in place. So let's first of all deal with the internal rates of return, just so we'll have a point of comparison across these interest rates. In the case of the IRRs we've shown previously, you simply want to go to your financial, or in my case under the more recently used, go to the function IRR, and then it simply asks us to highlight the values from time 0 all the way through. So you find that this has project A has an 11.1% internal rate of return. In project B's case, again, we'll go to the same function, the IRR function, and under that IRR function, we highlight the values in here. We find it has a 13.18% rate. Now, IRR, because these are normal cash flow projects, in other words, they start negative and go positive and stay positive all the way through, then we know that IRR and the NPV are going to agree on decision making. And what we'll find is that at a 5 and 10% rate, we're going to expect to see NPVs that are positive, but at a 15% rate, since the IRR is less than that, we expect to see these as negative values. So let's go ahead and put it in here for this series of cash flows. And what we'll do here is we want to go, we want to start off by recognizing, first of all, the NPV function does not deal with the situation of the time 0 cash flow. So we're going to need to add that in separately. Now the other part of this is I want to be able to copy this from column to column here for project A. So what I'm going to do is I'm going to lock this in as a value that I'm going to use here for column C. To that, I'm going to add my NPV, and NPV is, again, just going to the NPV function, again, here under either finance or, in my case, most recently used. And what I want to do is to, first of all, relate it to the rate. Well, the rate that we have is given here right above that column. And again, since I'm going to do the same thing to copy this for the line below it, I'm going to put a $ in here. Make it B$6 so that it fixes it at that 5% for the NPV for B as well. Now, as far as the values go, I'm simply going to take the values that work all the way through for the rest of this, but I want to be able to copy this from column to column. So, again, the $ is going to come in front of these, so it fixes it at those cash flows for each of the problems that I have. Now, when I tell it OK there, I indeed find a positive net present value. Now let me just copy this and paste this in place. Keep in mind what we said. We anticipate at 10% it will still be a positive NPV, but at 15% it'll be negative. So we'll paste that in there, and that's indeed what we get. Likewise, if I'm to look this for project B, we've seen similar types of things here where we expect positive NPV at these early levels, but negative at the last one. So we'll go ahead and paste that into place there. So we've got our net present value measures. Now, modified internal rate of return, again, is fairly easy to be able to use. What we want to do is we'll then go to our function wizard here. We're looking at the modified internal rate of return, so MIRR under either the finance menu or, in our case, the most recently used. The values we're going to be using is all that we would have in here for cash flows for project A. Again, since I want to copy this from column to column, I want to fix those in there by putting $ in front of the letters, both C and F, and that way it'll pick those things up appropriately. Secondarily, at the reinvestment rate, I'm going to use whatever rate at the top of that column, but I want to be able to fix that in place for both projects. So we'll do that by putting a dollar sign in front of the number to hold it at row 6. And what we're going to find here is an agreement with this. Namely, we anticipate that the modified internal rate of return will be above the 5% and below the 11.1%. And indeed it is. Likewise over here, since it's going to be somewhere in between the 10% and the 11.1%. So when I copy that and paste that in place, I can say yes, between 10% and 11.1 is what I get here, and between 15% and 11.1 is what I get here for the 11.99. So modified internal rate of return does not change what your decision was in the internal rate of return. It just gives you a little bit better feel for a measure that you might use as a return on investment. We'll see the same thing when we paste this in place here for project B, where we haven't changed the criterion in which we would decide upon these things. It just gives us a little bit better feel. Now, the second question that we had here was independence versus mutually exclusive. If these are independent, we're going to choose every project that has a positive NPV. So in this case, we would choose A and B, since they're both positive. Likewise, in the next case, we would choose A and B because they're both positive and they're independent. Adopting one does not affect the other. But in this case, we would reject them both because they have a negative NPV. However, in the case of mutually exclusive, we want to choose the one with the higher NPV. So if I'm looking at this, projects A and B, I find that project A is the better choice if I could only adopt one in this case here. But here what we find is B has the higher NPV. So we would want to adopt project B. And then in this case, even though we can only choose one, we can also choose none. And again, it would be a case of neither because they both have negative NPVs. And that's how you would compare both independent projects and mutually exclusive projects. This would be the mechanism by which we would do that.